the interfaces are. In our last video, we looked at installation of Wireshark and few other things that you need to know as a beginner, and today we want to move a little bit further. So we titled the one yesterday as Wireshark Part 1. This one will be Wireshark Part 2. So this one will be set your Wireshark capture mode like a pro. Wireshark Part 2. So to open Wireshark, I can just say Wireshark here because I've installed it, and it will give me this. But then this is not all I should have. So with this is Cisco remote capture. So if you have a Cisco remote device and you want to capture, this is the one you will use. And you have to, you can see remote SSH server ports, port 22, and so you have to put the address here and save it. Then you go here for the authentication, you put your password here, you save it, then you can go to capture. So, and if you are using it for a debug, so for debugging, this is what you see. Okay, let's close that. So I'm going to actually go out of this. Then here is the option, the same thing that you have right here. So you have it here, and you can see. So that is about that, and let me show you one or two things. Okay. You can see that though enable promiscuous mode on all interfaces is checked, but then you did not see promiscuous mode. Here it is. You did not see it checked on any of these. We'll come back to it. So let's look at manage interfaces. So here we are. These are the interfaces that are here now without signing in as admin. So let me say okay, and let me close it out. Your output, this is where you decide whether you want the output format to be pcap.ng or pcap, and whether you want to create new file each time and that you run a capture, or you can use the parameters like after 100,000 packets or 10,000 packets, or you want to use the file size. So you have your kilobyte there, and if it's about certain seconds, and this if it's about hour, it says switch to the next file when the wall clock time is an even multiple of the specified interval. For example, you say 3 hours. So once it is 3 hours, it will change and it will start saving the capture packets into the next file. And that's about that. Then here you can decide how many packets you want to capture. You can decide, so it will stop, the capture mode will stop after the parameter here is fulfilled. See, stop. Let me see. So if you put 200 here, once it has, so stop capturing after the specified number of packets have been captured. Can you see? Okay, so let me close it out and close this also out. Now let me now do sudo Wireshark, put the password. Okay, so we have the Wireshark up now. You can see that we have more interfaces now. Look at NOS3, that's the interface for the virtual machine. Then any, that's the one that capture all interfaces. Then look back, that's the local address, the packets that are that are captured as a result of communication between or among the applications within that same local network environment. So if on this local device applications are communicating with their dependencies, then those packets will be captured using this. And this one is what? This Ethernet cable. This is also Ethernet cable. Then Bluetooth monitor. And you have other ones. The ones I've shown you before. You can see these ones. Okay. So how you will know, as you see all this, if there are traffic going on here, you will see. Let me do something. Let me try, and you can see now that as soon as I click on the Firefox, there is traffic going on. So let me do scanme dot nmap.org. So we can go back and see what is going on. So let's pick any. See, I've just double click on any and you can see what is going on now. There's communication going on between the local device and the destination. So right now we have about 139 packets captured. It has jumped to 163, and you can see right here at the bottom, look at the bottom here at the right corner and see what is going on there. And if I want, I can also do this. I can see, you say no USB device attached, but let me and see the time 12:05 here. If I decide to attach this, it will also show up. Let me do this. So we have a 256 right now. I think I can decide to stop it here now. At least we have some packets to play with. Okay. So we have 284 packets. So 2 packets is 284 displayed. It's displaying 284. That's 100%. How many packets were dropped? 0. Look at the right corner here. 0. And profile is default. So we're using default profile. Okay. So we have seen that, and let's just move this a little bit down. You can see that there are different colors here. Yes, Wireshark and Wireshark has that for a purpose. So, and if you look at the display packets, you see that they are of different colors. And look at these ones: local DNS stub, localhost domain. So this is how you be able to, you can look at the ones that are flagged, and if you have a particular thing you're looking for, let's look through. You have number, you have the number of the frame. Okay, let me take it to the top, or instead of me scrolling to the top, you can just go to go, then, and so on and so forth, like that. So it's trying to reach many IPs and destinations. See, this is production.detect portal example server.com. So you can see local DNS stub example server. Okay, so that is about that. Now if you want to look at this critically, you go to statistics and you have conversation, and you can see the conversation within this particular capture. So for your IPv4, you can see the address A, that's the origin, and address B is the destination, and it will show you the packets exchange and the bytes, and also you can see packet A to B is meaning from the origin to the destination is 46. So from the destination back to the origin, you should have the number that will make this to be 93. So that's about that. You can see B to A is 47. So 46 and 47 gives us 93. You can see that. And the duration, you see how long the communication was. So that is about that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and you can see 16 up here, IPv4.16, because you have 16 IP addresses that are communicated with it. Okay, then this is IPv, and this is TCP 16, because that means they are TCP protocols. What about USB? No USB. Then if you want absolute start time, you put this, and if you go back to check, you will see it there. You can see absolute start time. Now let me remove absolute start time. Look at this one right here. I'm going to remove it. See, it's gone. And limit to display filter. So only show conversation machine current display filter. You can see underneath. Then if you come down here, protocols, you see protocols. if there is BPv7, you see it, this CCP Ethernet. So as you're clicking on it, it's showing up at the top here. Let's look critical. Let's do RSVP. Let me see, where's my cursor? Let's do UDP too. Okay, so we can go back now and do, so UDP we have 16, you can see. That's for UDP on these ports, and these are the bytes, and this is the stream IDs. Then go to RSVP, nothing like that. Go to CP16, see, that's port 53, 443, 80. Those are the 3 ports that are involved in the communication from the port B. But from port A, you can see the ports that were involved. All right. So these are the things you can do. So we can start removing some of these. They are not useful. Okay. Now let's go to flows. Let's follow the stream. So you can see now peers port 59420 and port 53, the packet, and this is the data. Here is the data. So, and for this packet 7, this packet 6, let me go back. This is, what packet is this? Okay, this peers. Okay, this for the DNS. Then you have packet 6, then you have packet 10, packet 7, 6, 7. I will show you something here. You need to learn something. Packet 13, you see that they are not arranged. Packet 22. Let's continue. Packet 27, packet 30, packet 33, 40, 42, 50, 52, 62, 74, 76, 85, 102, 106. Let's continue like that. One 65, 179, 191, 213. Okay, so you can see that they have a random IPs. These are the ones that are captured. So what happened is that when communication begins with the source, with the origin device, and is sending the packets out, it will cut the packets into pieces and send them. It is when they get to the destination that the destination will rearrange them to form a complete and coherent message. And that's why you have all these as different packets that are not in particular order, and you have some skipped because they are not yet captured. So you can change this, you can change it to another mode. Let's look at this. You can see how it is now. Let's go back. to IBM 284. See how IBM 284 is. Okay. HP Roman, and also ETF 8. That's it. You can see different so stream, let's see, ETL 7. Well, actually the one I prefer most is the one I used earlier, YML. Okay, let's try raw. You can see raw. I think by default it will come with asking, yes, it will come like this by default, but you can change it as I've shown you. You can see it. It's readable, but not like the other one. See, googleUserContent.com, detailed footer, the products. So that's how you capture, and analyzing the capture depends on what you want, and we have just done follow stream, right? So now we've done I think that's the one we've done is the graph. Now we follow the stream, follow UDP stream. You see it now. So this is the UDP stream. Let's look at it. That's number 188 and 193. You can see it. So we later look at how to interpret some of these frames. So frame 188 is what we are on now. Let's move on next. So we've moved on to frame 193. So that the frame is displayed down here. So here is a packet, and in a packet you have frame, you have the interface ID under the frame, you have the scooped capture version, then the capture version, then internet protocol version, you have the user datagram protocol, domain name, response. You can see this. So that is it. So, and this says, we are on 193 request in, the request for this response is in 188. So you can actually trace it to see. So if we do this, so this is a response to the DNS query in this frame. So let's scroll back. You see that we're in frame 193. It's telling us this is a request in 188, which is up here. So we still have a lot to unravel in this Wireshark tutorial. So just follow. I will make it in series so that everything will not be just modeled together, so that you learn bit by bit and become more proficient in it. Alright, so and you can save. So, and this is another thing you can do. You can look at the capture property here. So you can give detail of the capture, the name of the capture, the length, the hash, then the Linux code, cooked mode version, then the date, the first packet, the last packet, time it took to capture the files or the packets, and the hardware, the operating system, the application, then the interface. You know, we use any, you see, and other useful information. So I think for now this is where we will stop this particular tutorial, then we continue from here. If you go to specified packet, this one is go to the next packet. That's because it's not in the filter. Alright, so I'll see you in the next video. Thank you for